Good morning, good afternoon, and good evening, depending on where you're joining today. I just wanted to open up the broadcast to have people actually join, but then we'll be starting momentarily. All right, as we see more people getting started on joining us, I just figured we'll go ahead and we'll kick this off. All right, so welcome to today's 60-minute webinar. My name is Genevieve Cross, and I would like to welcome you to today's presentation. We have an exciting webinar today, but before we kick things off, I just want to go over a few housekeeping items. So first of all, today's session is being recorded. So if you miss any of the discussion points, or you want to perhaps watch this later on, you'll be able, or you even want to share this with a friend, this on-demand recording will be made available shortly after we conclude today's presentation. Second, that if you want to ask any questions or if you want to engage with today's speakers, please use the question tab that is over on the right-hand side of your screen, and we will be able to answer your questions or even include them in the live Q&A. And then third, we will be using the polling functionality in order to get to know you all a little bit better. So today's topic is transform your Kubernetes troubleshooting with powerful data correlations. And I would like to welcome today's speaker. I am joined by Mark Walker, who is the co-founder of StackState, as well as also Andreas Prinz, who is the CEO of StackState. Welcome, Andreas and Mark.
Thank you.
Thank you.
So for today's agenda, we'll be going over the data and dashboards, troubleshooting, talking about various different challenges, as well as also best practices, going through data correlation, why does it matter, and also going over the observability dashboard. And then Mark will be concluding the presentation with an actual demo. All right. In order to get started, let's get to know you all a little bit better by doing the polling functionality. Okay, so first question is, which of the following best describe your role within your organization? And we'll give you a few minutes, not even a few minutes, a few seconds to answer this particular question.
Obviously, it very well might be that there's another role, Genevieve, that's not listed in here.
That's true. That is true. I should have had other on here as well.
Exactly.
All right. So most of you have actually answered this question, so I'm going to close it and we can move on to the next one, which is...
Do we see the results, Genevieve, as well?
Yeah, we can actually show the results too.
Yeah, it would be nice.
All right.
And really interesting to see already here that quite a bit of people in platform engineering teams are having the role of platform engineer joining. That is definitely a pattern that we see popping up. Actually, for the better, it would have been good to have had the role of DevOps in here as well, because we still see a kind of a 50-50 split in these roles, really implementing cloud native practices, if you like, and some companies do that with DevOps engineers who did big CI/CD movements, etc. Others with platform engineers. But good to get this insight.
Yeah, definitely. All right, so let's hide those results and we'll share the next polling question. Which of the following telemetry types are you using for troubleshooting? So the first answer is metrics. The second one is metrics and logs. The third one, metric logs and traces. The fourth is metric logs, events, status, and config. And then we have other. So once again, we'll give you a few seconds in order to answer this particular poll.
Yeah, and the reason why we're asking this is probably also interesting to know is that we actually see a lot of different approaches in the market. There are the people who are really or solely relying on metrics. Some of them solely rely on logs, but often metrics and logs as the main ingredients to do troubleshooting. And then slowly less metrics, logs, and trace information, and then also using status and config. But since the majority of the people here are platform engineers, I'm expecting that there's quite a bit of the fourth option, using all the data types that are available from the cluster. So let's go to the results and see what it tells us.
All right.
Oh, that's exactly what I thought about. So what
your,
we
your
see,
prediction.
yeah. So what we see in the field is that the more you speak to the people who really own, obviously, the clusters, or are super familiar with how to set them up, the richer data set they can access, and the more complete picture they obviously get when doing the troubleshooting. So this answer, thinking about the previous question, isn't a surprise. So interesting. Yeah.
All right. So let's do the last poll, which is, which of the following tool sets do you use for observability and troubleshooting? Commercial tools like Datadog, a little bit of a typo there, Dynatrace, New Relic, a suite of open source tools like Grafana, Loki, kubectl, only Prometheus or Grafana. I haven't selected my observability tool yet, or other.
Yeah. Again, if I would give my prediction, but I'm not going to influence. No, I'm not going to say it before we show the results. Let me share.
All right, so we'll give you a few more seconds in order to answer this polling question. All right. Looks like most of you have answered it, so I will close this out. And do you want to share the results now?
Yeah, I'll share it. That's
All
fine.
right.
Yeah. Yeah. So indeed, so majority 50% here on open source. A lot of people only using Prometheus and Grafana, and that's really the big pattern that we see. If you start using open source tools, well, it's more, I would not say obvious, but a lot of them using Prometheus and Grafana, and sometimes next to that Loki in kind of one go. A broader set, 17%. I would have expected that a bit higher, looking at all of you being, or a lot of you being, platform engineers, but also commercial tools at 30%. That's what we often see indeed in the market. So.
But what we also see is that the minority only voted, so that might have influenced it.
Yeah, that's true in this case. Only, yeah, that's true for this question. All right, thanks a lot, Genevieve, for hosting these. And yeah, let's actually go a little deeper and try to understand, hey, what is it that we're aiming for? And in the previous webinars, we emphasized really the need for all these different data sets. Can you see my screen, by the way? Yeah. The need for the different data sets. And today we really want to go one step deeper and actually understand, okay, it's not about the data, but it's really what it's you're going to do with the data. And how I think about that is a kind of the most common habit, I would say, or the most common approach is, hey, there's data, and let's put that into a dashboard. Right? That's ultimately how we consume the data, and a little bit through our alerts and our Slack and Teams type of channels. But ultimately, it's not necessarily about the dashboard, but it's what it is that we want to do with these dashboards. And where we think about, if we think about troubleshooting and observability and increasing reliability, the purpose should really be to empower developers for efficient observability. Why? Well, ultimately, for the business reason, to increase reliability. And the interesting thing, what we see happening also with all of you on the webinar here, is that platform engineers often are super powerful in using the tools, the more technical oriented tools. But as soon as we move more towards DevOps engineers, or even regular developers who deploy to the cloud, they sometimes only have dashboards where the metrics and the logs show up, and not necessarily all the other tools to use config, status, or the Kubernetes events, etc. And the question that we would like to answer in this webinar is, how can we make developers, so the people who develop and deploy their apps to the cloud platforms, how can we make them more effective in doing the troubleshooting? And then the question that comes up and that we try to answer is, hey, if there's a ton of data available, and Kubernetes itself produces a lot of events and you can derive a lot of information, metrics, change information and whatnot. But how do we actually turn this broad and diverse data that flows into your observability platform? How can we actually build a better correlation, bring that nicely together to ultimately serve the purpose, not having dashboards, but having software developers who can become powerful in remediating issues. And then just to set the scene a little bit, if we think about remediating issues, the first thing that comes into our mind is, well, the question to answer, what is troubleshooting? And if you would go to the web, if you start Googling from an SRE perspective or a platform engineering perspective, you often end up with this the Site Reliability Engineering Handbook, with this little process that is described, and you can even find it on the internet, super clearly described, where there's a problem reported, and the question is, what are all the steps that you need to go through before you can cure the issue, before you can resolve ultimately what happened. And really, if you think about this, it already starts with a clear identification of the issue, and if possible, try to document as much details that are relevant to start the triage of the issue. And then there are 3 steps: triage, examine, and diagnose, that go kind of hand in hand, but are really focused on identifying, hey, where to focus on the triage, what really has the priority to look at, then build a really good understanding, gather the data that is needed to understand what the issue is, and then, if needed, go even one step deeper and truly try to understand and analyze what was the cause of the issue. And sometimes you want to fix it really fast and do the real root cause analysis a little later, because the ultimate goal of this process is to cure as fast as possible. So testing it, validating the theories, and then pushing a change out, and indeed check with your observability system that you have if the issue is resolved. And in our demo that will take a majority of this webinar, we'll go deeper in these steps, and we'll really try to explain on how to use different capabilities and different data sets to go as fast as possible through this scenario. And really important and often forgotten is try to understand the business impact. Really, what is the service that is impacted the most and that has a customer interaction? Because often we tend to look at signals, but not necessarily at the cause of the issue. So what we aim for is, if we want to empower the engineers, is to really help them, guide them step by step through this particular process, and really try to let them understand, what the issue is and how to resolve it. And we mainly, if we speak to our customers and if we engage, we mainly see kind of 3 challenges for troubleshooting, and probably a little less for the experienced platform engineers. But as soon as you go towards your software developers, the first challenge, they often say, for me, it's really hard to access all the different data types or telemetry that is needed to troubleshoot my issue. So it's not necessarily the lack of tools, or probably sometimes the tools, but really it's hard for them to get access. Metrics and logs, we've seen it also in your answer, they're often still there, but then the other data types that really give that broad understanding, they don't have access. And if you think about formulating a good understanding, on the previous slide, the examine and the diagnose, formulating a really good understanding of the issue, you really need to have that broad data set to understand what is going on. So that's the first one. Then the second challenge, and feel free to leave comments in the chat, is if you have a broader set of tools, and almost 50% of you answer that, you need sometimes to go from one tool to the other to build that full picture. And if you're an expert and you know how the Kubernetes is built up, how resources relate and what each of the resource types is, it's still doable because you know by heart what to do. But if you're a little less familiar with Kubernetes because you're a developer and you're super focused on developing product features, yeah, how do you actually know? And then using multiple tools can be pretty time consuming and probably even hard to navigate from one point to the other in a dashboard or between multiple tools that show you pieces of the information. So data navigation, and then the third one is what we see in the market is an issue is having knowledge on how to interpret signals. Because if you really need to derive conclusions only from dashboards, it might be a real challenge because, hey, how do you need to interpret an OMM kill? What are all these events like image pool issues or insufficient resource allocation? So the fact that you're lacking a deep understanding of particular issues and knowing how to remediate, yeah, the troubleshooting of issues can be pretty difficult. And that is a kind of the third challenge that we see and that we also take into account. And that's why we also think that building strong data correlation is important. But before I explain what we define as data correlation, there are actually two kind of reasons why you should, in our opinion, focus on data correlation, or really form an opinion or a strategy, if you like, as part of your observability strategy around this. And the first one, and that's probably the most obvious one, that's what I emphasized in the previous slides, is about efficient troubleshooting. The better the data is correlated, linked to each other, and easy to navigate, yeah, obviously, the faster you can go through that remediation process of triaging, examining, diagnosing, and solving the issue. And data navigation, we've seen and learned, is super important. But the second problem, or the second area where data correlation matter, is if your system is a kind of in an healthy state. So there are no alerts coming from Prometheus Alert Manager into your Slack or Opsgenie. The system is relatively stable, but still you want to improve and optimize your application. For example, to reduce cost. Potentially your footprint is way too big for the load that's running on your cluster. Or you want to determine if there's performance degradation when you start to deploy more frequently your app to production, and potentially the performance of your app is slowly decreasing. So although there's no urgent issue, like on the left side, there's still the need to have that holistic understanding of what is actually going on with your application. So these are the two main drivers that we see that data correlation from an observability strategy perspective is extremely important and valuable to focus on. But then the question is, what is actually data correlation? And I would like to use a picture of this pyramid to explain what we think is super important to do with your observability data. Because at the bottom, at the foundation of the pyramid, we have data. And in one of the polling questions, we've asked, hey, what is the data that you have? Metrics, events, logs, trace, change information, config, status. And that's all the data flowing into your observability platform. And then the first thing you need to know is, how are all the dependencies, how are all my components related to each other? So what is your dependency map? And with a pretty fancy word, it's called topology. Building a map of all dependencies, not only a service dependency map, but also understanding dependencies between your replica set, your deployment, between a service, a pod, a container, a process. And that is important because if you've built out that entire dependency map, the topology, then you've laid a firm foundation for the other things that need to happen. And a firm foundation to navigate from one component to the other. A foundation to determine if an issue occurs, let's say on a service, to determine what is the business impact. And really important, what we've learned is that by having a visual representation of your cluster, new people who join the team or who need to help out solving the issue build a much quicker understanding. So the topology or the dependency map is the first thing you need to have or you need to build with that data. Then the second layer is your correlation of, let's say, your telemetry data. So your metrics, your events, your logs. So imagine you have that extensive network of all dependencies laid out. Correlation of metrics to it is important because that not only gives an understanding of the dependencies, but really of the behavior of the distinct components in your landscape. So rather than going from one, we're here in a room where the lights shut off, but it will start up in a split second, I'm absolutely certain. And that's that we prove that it's actually a live webinar, right? That it's not recorded. Otherwise, we would have cut out this piece. The second layer is the correlation of metrics and really building that holistic understanding. And that's important because with the topology, you can navigate from one component to the other. And then, hey, if you have a good view of each of these resources, that's really helpful. So that's nice. Having data, be able to navigate, understand the component behavior. But then the question starts to arise, what is it that you want to do with that correlated data set? And obviously, if you think about reliability, you want to start to recognize issues that occur in your landscape. So that can be through anomaly detection, which is a kind of an autonomous way to detect issues, or with predefined monitors or policies, if you like, that validate continuously if your SLIs are in control, if you like. The goal there is increase efficiency for the detection and ultimately, in the next step, the remediation of the issue. So that is an important piece of the puzzle because you can think about data correlation, so find a way to correlate the data nicely from a technical perspective in your database. But the question, if you want to empower your developers, is also how do you group that in a really easy way that it's also easy to navigate and easy to understand and to interpret in your dashboards all the data. So rather than using multiple dashboards to go from logs to metrics to trace, the question is, can you pivot it around and really connect the data sets in the UI? Really focused to save time by the developers to navigate in a single screen rather than from one page to the other. And then last but not least, and I do think that's often forgotten, it's really about the resolution, because it's nice to have data and understand what's going on to detect issues, but ultimately you really want to focus on remediating issues and connecting your observability system into your automation systems to resolve or to scale up or to roll back, whatever is needed. And that is how then the data that comes in as fragmented data becomes refined data and ultimately turns into action, ultimately helping you to build a solid observability approach and strategy that will drive the reliability for the business up. And that's ultimately where we strive for. And this is also what we would like to demonstrate in the second half of this webinar with Mark. So Mark, I'm handing over to you. I'm curious to what's going on. So let me see if I can hand over the rights. There we go.
Okay. There we go.
I don't see it yet.
Oh, then I wait for a second.
Not yet.
I can reshare. 1 second. You see it now?
No. Genevieve, can you help us out?
Yeah, actually, I do see the screen.
Okay, cool. Then I just need to flip on my side. Perfect.
Yep.
Okay. Yeah, welcome everyone. Thanks, Andreas, for the great introduction about why you need a tool like StackState, or at least to implement the same type of strategies. What you see here is basically our play environment, which is an environment where some of our demo clusters report to show you basically what we are doing. One of the things we have here is a sock shop, and that sock shop gets a new issue injected every hour. So every half hour it's okay, every other half hour it's not okay, and it's showing an issue, which is easy to help people out and to let them explore our product also on our website. So what we can do here is we first of all can focus on the thing I am responsible for, or my team is responsible for. In this case, I'm responsible for a sock shop. I'd like to sell socks, which is a great business nowadays. Next to that, in this environment, I have two demo scenarios. One demo scenario, which is basically running the full sock shop on a single cluster. And the second demo scenario is running the sock shop in a multi-cluster setup. In this case, I want to focus on the second one. So I select the clusters where the sock shop is running. I could also have prepared this view and saved it, but I think it's good to see how you can navigate it. Next to the service topology which I show you, we also have all other types of resources which you have in your landscape, and we also automatically monitor them out of the box. In the end, it's a 5-minute install. We have an eBPF low overhead agent, which is easy to use. But here I really want to focus on the troubleshooting part. If you look to this picture, you see a picture of how it was at 8:26, and you see there's something going on. It's also always interesting to see how this gain. So in this case, what we can do is we can time travel back. We can see how was this environment looking before. And if we just go 2 steps back, we see that apparently this catalog service was not connected to the front-end service for some time, which is an issue. Then, if I see here, I see this ingress service. Basically, the ingress service is showing me a red dot, so something is wrong. If I click it, I also see that the HTTP response time is here alerting. So let's have a look at the full component.
So before you go there, Mark, just once this isn't really nice, but just to map it back to the pyramid I was just showing.
Yeah.
This is really that layer of topology where components are connected.
Yes, and also extending it already with the telemetry. As you can see on the right side, we automatically attach a monitor, see how it is behaving based on all the metrics we gather in.
Yeah, but this topology, I'm now only looking here at services.
Yeah.
But I explained that all components are connected to each other. Is that what we will discover in a bit as well?
Yeah, in a bit we will discover that as well. But also to show you, I can double click this ingress, for instance, and click here on the plus signal. We see now that there is a pod underneath it. And if I click the pod, I see that there is a container running. And in the end, in that container, there will be a process running and so on. So I can discover this full process. Luckily, I also have the ability to easily get back, and we go back to the point where we left off.
And just to give a bit even more background, the philosophy that we follow is that we try to make it as simple as possible. So we've abstracted away. If we would explode this full dependency tree, well, there are probably hundreds of components visible, but the philosophy is how can we empower developers to become effective in troubleshooting. And this picture is the start of the troubleshooting journey. And for now, we don't need to know more. Over time, and more data will become visible. But it starts with a simple understanding.
Yeah, maybe I can also show it in a different way. If I hover this relation or this relation, what you see basically is that we not only have here the front-end service, but we see that the front-end service is backed by a front-end pod. There's a container running. There is a process running on that container. That process is connecting to a different app. That process is running on a different container. That container is running for a certain pod, and in the end, the catalog service is backing it.
No.
So that's basically the full path which we are exploring here. But indeed, we try to make everything as clear as possible and as abstract as possible, so that you have a clear overview of what services are running and how are they impacting each other. But let me go into the ingress in this case. and see what we can see here. In this case, we get a dashboard. We have a dashboard for every resource in your Kubernetes cluster. Out of the box, it will automatically be populated as soon as you hit it. There's all kinds of interesting information here. We have the golden signals, which are automatically detected by our agents, all incoming traffic, the outgoing traffic, network throughput, and so on. But what I really want to focus on in this webinar is how do I troubleshoot an issue. So here we see monitors. Those monitors tell me what's this current state. And here I have one which is signaling a red status. In most systems, red means there's something wrong. So let's click on it. We now see that this monitor during a certain time triggered. It's in a critical health state. And it also automatically gives me the supporting metrics, which is in this case the latency, which was below 0.1 seconds, and now it's above 3 seconds. So apparently there's something going wrong. But it also shows me all the related health violations. So it does not show me only what the issue is on this component, but it also shows me the components below. But more important, it shows me how do I diagnose and troubleshoot this issue, this very specific issue, because it's not about diagnosing any issue, it's about diagnosing a slow service in this case. So here we see that the first thing it tells me.
Before you move on, so if you refer back to the process, that the triage, so there's a problem coming in, that's the monitor that is being flagged, and you can do that from Slack or Opsgenie. Then the first thing you need to do is to triage, so build a quick understanding of what is actually going on. That's almost what you did on the previous screen, by picking the one that started first or is the most critical. And now this screen already provides a lot of detailed information to go through that examine and diagnose stages to build an understanding of what is going on.
Yes,
correct?
And I tried to do it as slow as possible in this webinar, but I could have done it maybe in 30 seconds.
Yeah.
But let's try to do it a little bit slower that everybody sees what I'm doing and understands that. So for that, every monitor has its own remediation guide. You can also edit them at your own knowledge, which is the institutional knowledge you share in your company, which might be very specific things which also can happen. All the general things which happen in most clusters, we provide basically out of the box. In this case, there's a slow dependency, and this text below tells me that I have to look at the deepest dependency and see if there's something going wrong here. Now we see here this ingress. We are on the ingress. It's connected to the front end. It's connected to a catalog service, and here we also see that there is a pod underneath that catalog service signaling there's something wrong. So
you're using the topology, and so rather than just seeing the signal, this case the error rate going through the roof or the latency going through the roof, you're using the topology to navigate straight away to the components that might be the cause of the issue.
And the topology is not the full topology, it's only the topology with the related health violations, which are the most likely causes of this issue.
So rather than going over everything, you've sliced out or taken out a small portion that is needed for this particular issue to resolve.
Correct.
Okay.
And so on this pod, you see that there are two signals. First signal is there's an OOM killed signal. Second one is a restart for container signals. Basically, it doesn't really matter which one I click. Both will guide me in resolving this issue. So let's click on the restarts for container one. What it now does, it does go to this resource and to the remediation guide for the fact if containers are restarting. It also shows me what's the state of this monitor. It's in a deviating state. It means that, it's restarting a container. So between restart, it is working. But obviously, if it's restarting, there are also moments that it's not working and that you can have issues or at least broken requests. So here you see the evidence that it's restarting, the restart counter in this case. You here see the impact, because you can see we also include the impacted components. You can turn it off if you want. And
so this is interesting, because if you scroll up a little bit, the chart is the same. Because obviously, the topology is the same because the same components are involved in this issue.
But this now the one selected is the one where I'm now currently looking at, which is the catalog, and in this case it's the other way around. It's impacted the other.
Exactly.
So here we also get at the remediation guide. In this case, it's about a container which is restarting. It makes no sense to look at other services because there is no other service involved in the container restart, or at least that's not the likely cause. So it tells me go to the event section in the middle of the pod highlight page. So it tells me to have insights in the pod. So let's click that link. There we go. And now a few things happened. First of all, we get to a new page. We get to the catalog pod page for this instance of the pod. But also the remediation guide followed me. It's basically chasing me, which is great. Because it was chasing me, I can follow the instructions there easily now. So I can go now to the second instruction, and there it tells me look at if there are any events like backoffs, failed scheduling, failed attached volume, or OOM killed. And it tells me if there are to look at them in the alert category. So here we have the event section. You see all the different categories. You see that there is a deployment here, for instance, but you also see alerts here. So if we hover them, you see that in the out of memory category, there are some events. Then it tells me also go to the related events, and you can correlate them with all the telemetry. So what we can do here is we can shift click the things which we just detected, where we saw, hey, there is an out of memory, and it also tells me have a look at deployments which happened around that time.
That hovering that bucket went really fast. Can you open the alerts as a whole?
Yeah, I can also do that. So you can just click on the alerts, and then you see all alerts. So here you see an OOM killed event, and if I scroll a bit further, you see backoff events, and you will see some more out of memory killed events again here.
And you and I know where these events are coming from, but there might be people attending who don't know. So where does so at the bottom layer in the pyramid there was data.
Yeah.
So where does this particular set of data come from?
Yeah, this particular set of events comes from Kubernetes, but also from our own system, from StackState, from the monitors we have, but it can also come from your CI/CD system. So, for instance, those alerts can be fed by different systems. The deployments can be fed by different systems. So if you do a deployment via CI/CD, you can register that. And you are not registering the deployment on a pod, because a pod is something you create, which is automatically being created and killed. It's basically managed by Kubernetes. But behind a pod, somewhere you define most likely a deployment or some other workload. And in that case, you can just put the event on the deployment. And because we here include all the related resources automatically, and here you see basically what are the related resources in this case for this pod. Now it's a service which is behind it, a container which is running, and also a node on which it is running. There are no PVCs or other things connected, but if they were, they should have been shown up. And also all the events related to those will also show up.
And again, I'll try to tie it back to the theory. So there was data, then there's topology, and StackState is able to show super easily the related resources, because we first built that map on understanding how stuff is related. Therefore, also the related resource section, but that's used then everywhere in the system to build much faster an understanding of what is going on.
Correct. Okay. And also to automatically provision a dashboard for every resource in your system at any moment in time. Yeah. So now we see in this pod we have the out of memory events. We see that there was a deployment. So let's look further. It now tells me to inspect the logs, and it tells me have a look if there are any errors, which give you an indication what's going on. What I can do is I have here a log widget. I can click on errors. I will see all the errors, but there's a 0 behind it, so clicking on it might not do too much. I can also click on view all here, or I can just click on view all in the remediation guide. It does the same trick. It shows me all the logs of all containers in this pod for any severity in this case. And yeah, it's just info level logging, I guess, in this case. So there are no errors, no warnings. So I don't think the log indicates anything in this case.
So rather than navigating to a system, let's say Loki, and find out this particular pod and then the containers that were related,
and find out around the exact time frame where we see this happening,
we pivot it around and we bring the logs of the containers running in this pod at this moment in time into this screen.
Yeah.
So you don't need to navigate, switch between tools, context, etc.
Indeed.
But in this case, the logs don't tell us anything
No.
on the issue.
No. If we look a little bit further, you see also all the related telemetry. So here we see the CPU usage. We see that there is some CPU throttling. It's not a lot, so it might not be the issue. But here we see the memory usage, and we see a clear saw-teeth pattern, which indicates a memory leak and which indicates we have an issue with memory usage. So the next thing you want to do is, why did it happen? Now, also the remediation guide tells me, hey, have a look if there's a recent change. And for that, we can just here have a look at the deployments. In this case, we directly see there was a deployment. And for that deployment, I can even directly see what is changed. So we constantly monitor every resource in Kubernetes, and we see the runtime configuration. So in this case, we know that there is an 03.5 version of this catalog pod, and it is now an 03.6 version. So that indicates something changed there. And also, if we look back, the issue here, or this pod started at that moment, but that does not mean that the issue was introduced at that moment. But what I can also do is I just can click on the deployment. I can see here the catalog deployment. And on the deployment level, I can also see the CPU usage over time for all the pods serving that resource. In this case, we see the memory usage was just really low before the change, and after the change, it was skyrocketing. So obviously, this change was the cause of the issue. And yeah, you have to basically do a downgrade or change the code and make sure you get rid of the memory leak. Yeah, I think I showed most of the things I wanted to show. Is there anything you like me to show the rest of the?
Yeah, if you probably close the let's go over the concepts, because one of the concepts at the top of the pyramid was a single UI.
Yeah.
And this is such an example, and the pod, because it has the richest data set, or the widest data set, if you like, is the best example. We have the monitors, which show something of the health. Then we have the events. Mark explained that wide variety of data coming from multiple sources, but all rallying around that particular pod. Then there's already change information in there, which is another kind of data type. What were the deployments going into this cluster and what caused it? Then there are logs. And then really important, there are metrics at the bottom if we scroll down a little bit. And there's much more. If you think about the Kubernetes metrics flowing into the system, there's a ton more. But from a troubleshooting perspective, we've discovered that CPU usage, CPU throttling, and memory usage are kind of the most important to troubleshoot the majority of the issues. If you need more, you go to the metric perspective at the top, shift 4.
Next to the golden signals.
Next to the golden signals, obviously. Yeah, sorry.
And I can just use shift 4 indeed, go to the metrics section and see all the metrics related to the spot, where we also see things like the pod ready states, the amount of scheduled pods, container restarts, and so on. But container restarts, it's only interesting to see if there's something going on there. And stack state automatically monitors them out of the box there, so there's no need to constantly look at those.
Yeah, that's really nice. So there are at the same time, there are a couple questions coming in. I would like to address them here straight away.
Sure.
So the first question that was asked was, what is the level that stack state can detect and remediate? Good question, and remediate straight away. And what we see here is that every resource type, pods, in this case, have 5 different monitors. The restart, OMM killed, pod ready, pod waiting, and completed. A service has out of the box 3 monitors. A cluster has out of the box 1 monitor. So really little bit depending on the resource type you're looking at, there are particular out of the box practices defined. And then what we do from a remediation perspective is we give the remediation guide. That's where the knowledge, as Mark explained, resides from the platform engineer or the cloud engineer. And that's where the experts can enrich it and work that way.
And we're also getting more out-of-the-box monitors all the time. And also you have the ability to create your own monitors, select your own signals, and not only monitor on metrics, but also monitor on your topology, for instance, to see if there are certain paths also always available, if configuration is in the way you expect it, and so on.
Yeah. And then there's one other kind of question encapsulated in the question, and that is, what about the remediation? Because in this case, the remediation is guided, so it's the engineer who goes over it and does then the heavy lifting to remediate. There is the ability to hook up with your existing, let's say, CI/CD pipeline and practices. And the reason for that is really simple. There's not a lot of larger companies who really like to have a button in an observability tool to say remediate or change config or whatever, horizontally scale or these type of actions. So that was what we originally had in mind, but what we've now delivered, and it's not in this demo, but you can link through webhooks into your GitHub Actions or your Argo CD or Jenkins, whatever pipelines, and then execute actions that way. And we think that is also a better way, because then you just follow your regular change process that is most likely compliant and secure how your organization should do that. So that's addressing the first question, and thank you for answering. Then another question that just came in is, how is it deployed and where are the metrics stored? Well, it can be so under the hood, and that is important to call out. Probably you can show a SQL query, Mark, of the CPU usage, for example.
Yeah, sure.
Sorry, the PromQL query.
Yeah, sure.
So we make use of a PromQL-like metric store. So there's Victoria metrics under the hood, and we utilize then PromQL to query that metric store. So if you're a Prometheus Grafana user, well, the migration is super simple. There is barely any migration because you just point to our metric store, and you're good to go, and you can land your Grafana dashboards.
And you can also bind your metrics into StackState.
Yeah,
because we have a way to bind metrics to our topology in an easy way.
And that's what our users use for more business-oriented metrics. And then the other half of your question was where to host it. Well, let's discuss that in more detail, but it is a SaaS offering or it's an on-prem offering. So you do it yourself, self-hosted, or we host it for you, the metric store. And then you only install the agent in your cluster, runs as a daemon set to get the data into StackState. Yeah, and then the goal of these monitors and remediation guides, they really go hand in hand. So each unique detection of an issue has a unique remediation guide that will help you to solve the issue as quick as possible. So the topology is the foundation. Then the data is nicely brought together or correlated to kind of under the hood and visible in the UI. And then the issues are detected through monitors, and the remediation, what we have in mind, is really focused to get it out to the remediation guides or connecting to your own CI/CD systems.
Yeah, I also see some questions about contact information from multiple people, and also if we will share the deck. And yes, we will share the video afterwards, and we'll come back on the private ones also.
Yeah. All right, let me finish this up. Let me see if I can make myself presenter. Show my screen. It's pretty smooth. All right, so we've covered these, and then a few more closing words on what it does. It's kind of a repetition, but if we take the blue box, the topology will help us to enable new team members onboard faster, because in one go you see how everything is related. And probably, I don't know if it's more important, but really important as well is it helps you to understand where to start troubleshooting. And Mark was demonstrating a relatively simple 17 microservices application, but StackState is applied at many banks and big telcos, and then you can have topology that stretches an entire payment chain with 20 business applications and probably 2,000 or even more individual components under the hood.
And the great thing there is that we abstract it away, and then you just don't look at the individual service, but you look at the individual pieces of the chain and then go deeper.
Exactly. So that is really a powerful capability to have in your observability suite. Well, then the second one is, what if you have all the data in that single UI? Well, it accelerates, obviously, what we've seen, issue resolution, but probably more important is it lowers the cognitive burden to all your developers. And if you are a platform engineer, and almost 50% of you were in that role, it will also lower the burden on your team, because ultimately you receive less calls of troubleshooting issues because you've made the teams more autonomous by giving them a better development and operations experience. And then last but not least, the remediation guide is really focused on driving issue resolution. And if you do that, if you give that to your teams, ultimately they become more autonomous because they can do the troubleshooting that you do and that you have here in your brain. They can do that themselves, and therefore you can focus on platform development, etc. And for the teams, really important is if you can solve an issue much faster. Well, what can you do? Well, focus on the things you like the most, developing new features and capabilities for your end customers. So data correlation is not just something fancy. It's not something that you would use kind of as an afterthought, but it should be something you should, in our opinion, consider and really taking into account when building this solid observability strategy. I hope you liked. There's obviously a way to give it a try. If you go to our website at the top right, there's an Explore Playground. You can just try out the full demo environment that Mark was just showing on yourself. And if you say, hey, I really want to try this with my own data and see how that behaves, yeah, that's also possible. And with having said that, I do think, Genevieve, there's still, I don't know if there are still more questions coming in, but there's still room for a few questions.
We still have a few minutes for a few more questions if there are any more questions that anyone wants to ask. So please go ahead and enter those into the question tab. But one question that has come in was, you demonstrated the event timeline. Can you elaborate in more detail what all the different event types are that you show here?
Yeah, sure. We have basically alerts, which are really the alerts something is going on.
Can you show it probably?
Yeah, of course.
Or did you close everything already?
No, of course not. You should be able to see it now. So we have alerts, which are really the alerts going on. Activities, that means that the cluster is doing something for you. So a pod is scaling, or a pod is being created, and so on.
Can you open that one? Just to...
Yeah, of course. So creating a container catalog, pulling it, starting it, and so on. So all the things happening in the cluster, which in many cases is not the thing you want to focus on, because most likely, but it might very well be that if you move a pod to a new host, it can have effects. And if it has effects and you see a correlation with your alerts, it's important to know. Yeah, changes are really configuration changes. So if you, for instance, have some config map or some secret, you change it, it's a change.
So why is that empty in this case?
Because there were no configuration changes
in this time window.
In this time window, and I also don't think in the longer time window, because that's not in this scenario.
Okay.
And then the deployments, those are really. Oh.
No, go ahead, Mark.
Go ahead.
The deployments are really the deployments which you're doing, if it's Helm or Argo CD and so on. And the other events are things like an alert which gets closed, or the less important things in most cases.
And imagine I have some security scanning going on, runtime.
Yeah.
And that system is, let's say, Palo Alto, whatever, Prisma Cloud type of solution. Where would that then show up? Is that then?
It's will most likely also alert.
An alert.
Yeah.
And then you can take action if you're notified. Okay.
Yeah. And the beautiful thing is also that next to our out-of-the-box monitors, external systems can also send external state to stack state and give their own remediation guides with that. So yeah, also that can be shown up directly in the monitor section.
For example, hey, if there's a security, a CVE or whatever, and you know how to, well, I don't know if that's the case, but if there's an issue going on, right,
Yep.
and a container that comes from a repository that shouldn't be allowed, you're warned and can take action straight away.
Yeah, or if in a container is doing actions it should not do and it's killed, we can correlate that. And in one of our upcoming webinars, we also will show that to the partner.
Cool.
All right, I think we have time for one more question, which is on that pyramid at the top, you listed remediation. Can stack state also execute activities in the cluster itself?
Yeah, that's what I briefly mentioned. So I'm glad that you're asking. So stack state itself doesn't execute any remediation or any actions in your cluster. And I mentioned that's on purpose because many larger enterprises don't want to have everyone clicking on buttons and doing stuff without really knowing or making sure what is going on. So the answer there is a no. Stack state cannot do that. And at the same time, it's a yes, because what we see is if you think about the DevOps cycle, with the two circles connecting together, ultimately you want to close that loop. And on the dev side of the house, the deployment, there are many automation tools readily available that will execute in a really controlled manner the changes to production. So that is our philosophy, is that through webhooks, you can trigger any system that you already have, and that's how you can avoid any security violations or redeploy or roll back or whatever you need to do to solve the issue. So yes, and we think that should not be a kind of a future state, but that should really be part of your observability strategy, because the more you can automate in that sense, the more reliable your stack can become.
And a perfect example there are persistent volumes. You don't want to manage your persistent volumes all the time if they grow. Obviously, you want to get an alert and see if something is getting out of hand. But if you get an alert in 4 hours, it will be full. You want to take automatic action.
Yeah. And that's you can define that per monitor if you like. So it's not that's one to rule them all, but you can set it up really fine-grained and say, hey, in this case, in this situation, execute that particular action and move that forward.
Indeed.
Cool.
All right.
I really appreciated it. So thanks for having us, I would say, and glad you all joined.
No, and thank you all for joining us today, as Andreas said, and this will conclude our webinar presentation today. And as I mentioned earlier, that we will be sending out a copy of the on-demand recording. Thank you all.
Thank you.
Thank you. Have a beautiful day.
Yep, bye-bye.